Hello my dear learners, welcome to my channel. In this video series, we are learning Java programming language with a practical demonstration. In the previous video, we learned about what is thread lifecycle and 3 ways to create a thread practically. To learn that concept, please watch my previous video. Now, in this video, we will discuss about thread synchronization practically. So, let's start the session. First of all, let's understand what is thread synchronization. When two or more threads try to access the same resource simultaneously, it causes the Java runtime to execute one or more thread slowly, or even they can suspend their execution. To overcome this problem, we have a thread synchronization. Synchronization means a coordination between multiple processes and multiple threads. So this is what the thread synchronization. When one or more thread want to access the same resource simultaneously, it causes the Java runtime problem. And sometime what happen? Your thread can be a slow, or sometime your thread can be suspended their execution. To overcome this problem, the Java support thread synchronization. Okay, so the synchronization is used to prevent thread interference in between, and it is used to prevent consistency problem. So there are two types of thread synchronization: mutual exclusive and inter-thread communication. These two type of threads synchronization available in the Java. So you can understand that also in a computer there are multiple processes are running. That means multiple threads are running. Okay. So a mutual exclusive helps keep a thread from interfering with one another while sharing the data. This can be done by three ways in Java: mutual exclusive by synchronized method, mutual exclusive by synchronized block, and mutual exclusive by a static synchronization. So if you want to do the mutual exclusive, there are three ways: by synchronized method, by synchronized block, and by static synchronization. Synchronization is built around an internal entry known as the lock or monitor. Every object has a lock associated with it. Okay, so every object, when you create an object, it has a lock by default with it. By convention, a thread that need consistent access to an object field has to acquire the object's lock before accessing them, and then release the lock when it's down with them. When the process is completed, the lock can be released. Okay, so suppose if an object want to access the resource continuously, consistency, at that time it need the lock. So suppose in a computer there will be multiple process and threads are running. So how it is working one by one thread, it is totally depending on the computer and operating systems algorithms. So there are three ways to create a thread that we have done in our previous video: by using extend thread, by implements runnable, and you can create a thread anonymously also. So this is the three ways that we have done in our previous video to generate a thread. So here I am creating a new file. In that file I am creating a class name as a thread synchronization. Okay, and I am just copying this class name. I am saving the file with the same class name, thread synchronization.java. In that I will write a public static void main. So main is our starting point of our program execution. So in this program we will do the thread synchronization. For that I need to create multiple threads, and for that I will create multiple class. Say for example, class test extends the thread. Okay, so this is what the basics of thread that we have discussed in our previous video. You can watch that video also. I am creating another class test1 that is also extends thread class. Okay, so over here we will create a two thread, one for test class and one for test1 class, and here we are extending the thread class in the test and test1 class. So these both class has its own constructor also and can be override a run method. That is also we have seen in our previous videos. Over here I am writing a constructor for the test class, and in that constructor I will call a super. Over here I am just creating another constructor for test1 class, and in that test constructor and test1 constructor I will call a super. So there is a super keyword used to call a super class constructor. By this you can generate your thread. So over here I will write my thread 1. So this is my first thread over here. I am copying this and paste it over here. This is my thread 2 over here. Okay. So what we have done, we have generated two thread over here. When we create an object of the test and test1 class, it will create a thread. Now I am starting both the thread. Okay. Test1 thread started and test thread started. So when we create an object, this constructor will be called. Over here I am writing, I am overriding public void run method, and in that run method I am copying this code and paste it over here also, because the test1 class is also overriding the run method because it is also extending the thread class. So over here what I have done, I have created two class with a constructor which extends the thread class, and we have called a super, and then we have started the thread. You can write in the run method, say for example system.out.println. In the println method we will pass a parameter as a new date. Okay, I am copying the line and paste it over here. So it will print the current system date and time. When the run method is executed, it will print the current system date and time. Now I am creating an object of the both class test t equal to new test semicolon and test t1 equal to new test1. So we have created a object for the both class, test class and test1 class. Object name is t and t1. Now I am opening the cmd, increasing the font size of my cmd. I will go to the file location. My this file is available in the D drive. In the Java folder there is a thread folder. I will compile the file first. Java C thread synchronization dot java. Okay, what is the error? Bracket expected. Okay. So this date is a constructor, so I need to write brackets over here. I am saving the file, compiling again. Okay, another error, cannot find symbol date. To use the date class, we need to import the class. So I will write import java dot util dot date. Now it is compiled successfully. Okay. So now I am running the file java thread synchronization, enter. When I will create an enter, it will create two objects, and these two objects will generate a thread and start the thread, and it will print the current system date and time. See over here we are getting the current system date and time. So this start method we called two times, and we have overridden run method for each and every class over here. Okay, so this class test has a start method, class test1 has a start method, and have override run method for both the class. So this is just a simple thread that we have generated. Okay, so you can see over here when this thread is started, it will call a run method and print the date. When test1 is called, it will start a thread, and start method will call a run method, and the new date, current date, will be print on the console. The thread is not working simultaneously. Now I am just changing the parameter over here. This is my thread 1, and over here I will print this is my thread 2. Now I am compiling again and running the file. Now what we will get in the output, thread 1, thread 2. I am running again, thread 1, thread 2. I am running again, thread 1, thread 2. So you run this program multiple times. Each time there will be a thread 1 first and thread 2 will be the second line, because we have started the thread, but we do not have make your thread in the wait state. Okay, so if you put thread dot sleep over here, at that time it will looks like your program is running abnormally. So currently there are no any problem, because we have created two objects, and a particular object has started the thread and called the run method, and there are no any big process. It is just a simple thread which are printing the value on the console. So there are no any problem. So multiple threads are running, but this thread, you can see in the output, I am running multiple times. Every time I am getting the same result, thread 1, thread 2, thread 1, thread 2, because there are no any synchronization is required for these. But what if you will call a thread.sleep? At that time your thread will be going into the block state, in the waiting state, and when one thread is moved to the block state, in the wait state, another process will start the running. So at that time you need a thread synchronization. See, in the computer there will be multiple threads are running, okay, and every thread needs particular time to run. When one thread is running, it will, after some time, it will going into the wait state, and when a thread will go into the wait state, the another thread will come and start the processing of the particular object. Okay, so there, at that time we need a thread synchronization. To do so, I need to create another class that will use to go your thread into the sleep mode, and then when your thread is going into the sleep mode, the another thread can be in the execution. At that time we need a synchronization. So what I am doing, I am just removing this print statement over here, and over here I will write for loop, and I will start integer I equal to 1, I less than 15, semicolon, I plus plus. Okay, and I will write over here thread dot sleep. So now I am moving my thread into the wait mode for the 1 second. So when this thread will go into the wait mode, another thread will come into the process. So I am writing over here also. This loop is starting at the first in the 1 and ending at the 15th value. So now I am saving the file. So I am just removing this for loop from here, and because I just want to give you the demonstration with a different approach, I am creating a class table over here, and in that table I will create a method public static print table. This print table method will have a parameter, one parameter integer n, and this method is used to print the table on the console. So when user will enter the value, say for example 5, it will print the table of 5. In that I am writing the for loop for integer I equal to 0, I less than 5, I plus plus. So starting point of the loop is 0 and ending point of the loop is 5. In the loop I will write system.out.println. In the parameter I will put I into n. So this will help you to print the table of the particular value on the console. So when this method is called with a parameter, and in the output we will get the table of the particular value I into n, I into n. Okay, so every time I will be n will be fixed and the value of I will be from 0 to 5. So now what if I want to call this print table from my run method? Because you can see the print table over here, I will write system.out.println just for the /n purpose. So now I want to call a print table method. A print table is a static method, so I can call this method by the class name. This is what the use of the static keyword also. So I will call table dot print table method. In that method I will pass a parameter, say for example 5. Now I am saving the file. See in the code, this is what the actual code is, but there are no any thread.sleep over here. I am copying this line and paste it in this run method. For the test1 class, I will call the print table method with a parameter. So first of all I am compiling the file. Okay, invalid method declaration, return type required. Okay, so I will write public static void over here because this method do not return any value. Now I am compiling the file. It is compiled successfully. Now I am running the file Java thread synchronization. Okay, the loop will start from the 1. I am compiling again and I am running again. So when this program is run, this will looks like 5, 10, 15, 20, 25. You can see over here we are getting the table of 5. So I will remove that print ln over here. Compiling again, running again. Now you can see over here we are getting a value 5, 10, 15, 20, 25. So it means that we have incremented our value with a 5 every time. Okay, so now I am copying this line paste it in this run method with a different parameter. Now I am giving the parameter as a 10, saving the file. So when test one object created, we'll call a constructor and start the thread, and it will call a print table method with a 10 value, and this 10 value will go into the n parameter in the print table. I am compiling again, running again. You can see 10, 20, 30, 40, 50. You can see my thread 2 is started first, and then my thread 1 is started. This is also another problem. When this program will be run, sometime what happened, your object 1 will start first, sometime your object 2 will start first. See over here, I am compiling again. I am compiling, running again. Now you can see my object 1 is started first, and after that my object 2 is started. So this is what the problem is. You cannot manage, you cannot judge that these object will run first and these object will run second. To overcome this problem, we have the synchronization. And also when you call a thread.slip method, there will be also a problem occurs, because at that time your thread will be goes into the wait mode and another thread will be start the processing. So there are two issues. You cannot synchronize that object from your side, because the process in the computer, there are multiple processes are running in background, and if your thread got the time to run, it will be executed, and after some time your thread, your user defined thread will be goes into the wait mode, into the block state. So it is depending on the processor. Okay, it is depending on the processor and processes which are running on the computer. So when you start your computer, there will be multiple processes are started internally, and on that main thread, your thread is also running. So when your thread, your user defined thread got the chance to run, it will execute, and after some time it will automatically goes into the block state. It is depending on the algorithm of the operating system. So you can understand like this also. You cannot manage, you cannot judge like my these thread will execute first and my these thread will execute after the second. See over here, when I am compiling again, my thread is my execution is changing. Now what happened? My second thread is running first and then my first thread is running. So it is working like as abnormally. It is not in your hand to run the thread as per your requirement. To do so, we need to create a synchronized thread. So if you want to manage your thread by your hand, it needs to be synchronized. So let me write thread.slip over here, so you will have the proper idea. What I mean to say is, when this print table is called, this will print the value, and then over here I will write thread.slip with 1 second, so I will write 1000 over here. Every time this loop is executing, your thread will be goes into the wait mode. Okay, when I am going to compile the file, we are getting an error, must be caught or declared to be thrown. So this thread.slip need try block to write. Over here I will write try block, and I will write a catch block, and in the try block I will write thread.slip with 1000 as a parameter. Okay, I need to provide the scope for the catch. So now saving the file, compiling the file, compiled successfully. Now I am running the file Java thread synchronization. Now you will get a output like as a 10, 5, 10, 20, 15, 30, 20, 40, 25, 50. So it is working like as a randomly. It is working like as abnormally. Your thread is not in your hand. To manage your thread, you have to do the synchronization, because every time you run this program, you will get a different out. So these two main usage of the synchronization to prevent thread interference, to prevent consistency problem. So see over here, we have created two objects, and every object has particular thread. Now you can see over here, currently I am getting the same output, but if you run this program after some time, you will get the different out. At this point, see over here, now my output is changed. Now my output is 5, 10, 10, 20, 30, 15, 40, 20, 25, 50. So this is not in your hand to manage the thread internally. So it is the synchronization used to prevent thread interference. So one object cannot interfere in the another object, and to prevent consistency problem. See over here, there is no any consistency we are getting into the execution. When you run this program, you will get a different out every time, depending on the processor. depending on the processes which are running on the computer. Sometimes it may be the same, sometimes it may be the different. See over here, and now I'm running again. I'm getting the different out. So to prevent this, we have a synchronized keyword. There is a simple keyword available in the Java, and the keyword name is synchronized. So we have a two object. Every object has its own thread with the sleep mode. When first thread will goes into the sleep mode, another thread will come into the execution, and that's why we are getting the different output every time. So to manage your thread, your method should be synchronized. When the print table method will be called, it should be in the synchronized mode. So the synchronization process is also used to coordinate between multiple process and multiple threads. So if you want to coordinate the threads by your side, the synchronization will be used. So to prevent this problem, to manage your thread, there is a synchronized keyword. I will write in the print table before the public keyword. I will write a synchronized over here. So synchronize is a keyword in Java. It is used to make your thread synchronized. Compiling successfully. Now I am running the file Java thread synchronization. We are getting 5, 10, 15, 20, 25. After that we are getting 10, 20, 30, 40 and 50. Now you can see over here our program is not running abnormally. It is not running by the system. So every time you will run this program, you will get the same output because we have synchronized our two threads, and it will internally running in the synchronized manner. So I am just copying this and paste it before the test 1. You can see over here I am saving the file. Now I am compiling again, run again. Now my second object will be called first for the T1, and after the execution of T1, the T object will start its working. Okay, so this is what we have managed our thread by the code. So you can manage your thread in the Java by using synchronization process, and to do the synchronization process, your method should be synchronized between the threads. So this is just a keyword available in the Java, name is synchronized. You can manage your threads in the synchronized manner by using the synchronized keyword before the method. So now if you run your program multiple times, every time it will get the same output. You have managed your threads by your own. Now your threads is in your hand. Manage your object calling, and then you can manage your process also. We have prevent these two problem, thread interference and consistency problem, because our thread is not interfere in between, and there is also a consistency available in the thread. So this is how the thread synchronization is working. That's all from my side in this video, guys. In the next video, we will learn about a join method of thread class practically. Till then, stay tuned to my channel, like, share and subscribe to my channel. Thank you, guys.